Hi, here's Li Huang from Hughes Training Group. Today, I'm going to talk about the Jupyter Terminal installation and commissioning procedure. This video focuses on the general procedure in Jupyter Terminal installation and commissioning for Hughes Jupyter Worldwide System. For different types of Jupyter terminals, you should refer to the related terminal installation manuals. This is Part 1. Before we start, let's watch a video clip. It is a fully installed Jupyter terminal in a residential home in US. After watching the video, you can see the Jupyter terminal is quite simple. It basically consists of three parts: indoor unit, which can be HT2000, HT2300, HT2500, etc. Outdoor unit, which includes radio, antenna, and antenna mount. And the last part, IFL cable.
This is my outdoor unit from Hughes, an antenna, and you can see the ODU there. The IFL cable comes in, comes around to there, comes down the pole, buried out around there, then it's attached to the house there, comes down here, goes in, and then over there is a grounding block, and then it is grounded to the electric tower, the electric box there. You can see the grounding piece at the top, I hope, on the back. And then it goes up and over the door, comes down around this way, goes in here. And then I'll take you inside to show you the indoor unit. Now, I want to point out one of the reasons we have this. Right there is a security camera. Right there is another security camera. There is a security camera down there on that building. So I'll show you how I get signal down there. But this is at my mountain property. There is the where it comes in. The outdoor unit comes in from outside, goes under there, comes up through the desk, and then you can see the IFL cable, power, and an Ethernet cable plugged into port 1. Now, also, here you can see 6 LEDs. They all need to be lit up. The bottom one is showing Wi-Fi activity. The Ethernet cable I run back through here, down this hallway, to another router here. Now, like I said, the receiver, it has a built-in Wi-Fi, but I need to get long range. That Wi-Fi covers the inside of this house, no problem. This is a big house. I put this one here because I need to get all the way down the back of this yard. And what we use that for is video surveillance. There's a shed down here that has cameras on it and a Wi-Fi extender down there that connects to this Wi-Fi. And when we're here, we use it for web browsing.
A Jupyter terminal must go through installation and commissioning procedure before it can carry the user traffic for end user. Let's talk about the terminal installation and commissioning procedure based on the timeline. First, after installer is scheduled to install a site, the installer needs to do some preparation. If the site is a business location, the site survey is usually required to determine the IDU location, ODU location, IFL route, and any permits required. IDU refers to indoor unit. ODU refers to outdoor unit. IFL refers to inter-facility link. Installer needs to gather items and materials for site installation. Terminal indoor unit box, radio, antenna assembly, antenna mount, tools for antenna installation, IFL cables. For antenna pointing and site commissioning, installer needs to access to the terminal web GUI via laptop or smart device. The laptop is most popularly used for the international customers. The installer will need to have the site ID, SBC file, or ODU file. Every terminal must have the unique site ID. The terminal with the unique site ID should be already created in the Jupyter Network Management System. SBC file is the same for all the terminals in the same Jupyter system. ODU file is only required if the terminal use commercial L-band radio. The site longitude and latitude are required during the commissioning. The installer can get this information via smartphone app or GPS device. The site location is critical, especially for Ka-band satellite system, which usually has multiple beams. Wrong geographic information may cause the terminal commissioning fail. The accuracy of the site location should be in fractional minutes, up to 3 significant digits. Hughes Di6C antenna pointing tool, DEPT, can be used to assist the antenna pointing. The third generation of the Hughes DEPT, which is yellow color, can also be used in transmit cable calibration. Then what is the next after preparation? After preparation, the installer will visit the site and install the terminal. During the site installation, the installer needs to cable the site properly for site commissioning. Here, it lists several situations for site cabling. For terminals using Hughes radio such as HT2000, HT2200, etc., there is only one IFL cable between indoor unit and the outdoor unit. If the Hughes antenna pointing to depth is used, it will connect to the IFL cable outside, and a temporary cable is used between the radio and the depth. For terminals using commercial L-band radio, such as HT2300, HT2500, etc., there are two IFL cables between indoor unit and the outdoor unit. If the Hughes antenna pointing to depth is used for antenna pointing and the transmit cable calibration, it will connect to the end of the transmit cable outside. For antenna installation, please refer to the manufacturer's document. For IFL cable installation, it is the site-specific. Once the IFL route is determined, the installer needs to install the cable and make the cable connectors. For the whole site installation and commissioning, please refer to the related Hughes Jupiter terminal installation manuals. We are going to show you two video clips related with the terminal installation. It is the 74 centimeter antenna installation. The other one is the IFL cable connector installation.
These are the components of the General Dynamics SATCOM Technologies antenna for EchoStar 17. This is a 74 centimeter antenna. This is a 74 centimeter reflector. This is a reflector bracket, the tilt plate and Azel mount assembly attached to this bracket. This is the Azel mount assembly. This is the tilt plate including the bolts and nuts to attach it to the reflector bracket. This is the feed arm that attaches to the reflector bracket. The radio mounts on the end of the feed arm. This is a radio assembly. It is comprised of the feed horn, polarizer, transmitter, and receiver. It utilizes a single RG6 cable connection. Now we will show you how to assemble this antenna. Attach the As-L mount assembly on top of the reflector bracket. Underneath the reflector bracket, hold the tilt plate and line up the holes. 5 half-inch carriage bolts will run from underneath through the tilt plate into the As-L mount assembly. Attach by hand the reflector bracket assembly on the back side of the reflector with 4 half-inch carriage bolts. A Phillips screw is used to attach the bottom of the reflector to the reflector bracket. Once the Phillips screw is in place, you can tighten all the bolts to their proper torque values. Some bolts may be easier to tighten using a socket rather than a wrench. Attach a feed arm to the reflector bracket using two 7/16" bolts with flat washers and lock washers. Tighten to the correct torque values. If you over or under tighten these bolts, it can cause severe pointing issues by moving the focal point away from the center of the reflector. Attach the radio assembly to the feed arm carefully. It must be fully seated with no play. Underneath, the radio assembly attaches to the feed arm with a single Phillips screw. Tighten to the correct torque values. If you under or over tighten this bolt, it can cause severe pointing issues by moving the focal point away from the center of the reflector. The radio assembly comes shipped with a polarizer in the right-hand circular polarization setting, RHCP. After entering your latitude and longitude into parameters page of the System Control Center, the modem will calculate the correct polarizer setting. If it indicates RHCP, right hand, then no adjustment is necessary. If it indicates LHCP, left hand, then the polarizer will have to be rotated 90 degrees, moving the arrow from R to L. Inspect the end of the polarizer to make sure the O-ring is properly seated. Rotate the polarizer 90 degrees in either direction. The arrow will now point at the L, indicating left-hand circular polarization, LHCP. The antenna assembly is now complete.
We are here today to demonstrate the installation of compression fittings onto an IFL cable. We have our connectors, wire stripper, compression tool, weatherproof tape, phase tape used to mark the IFL cable for transmit and receive, and a 7/16 wrench used to tighten the connections, whether it be on the outdoor unit or the indoor unit. To begin with, we take our cable and make a nice, smooth, straight cut on the end. And we will now apply the wire stripper to strip back the shielding. This is a spiral type wire stripper. You'll notice the two steps in the cut, one here, one here. We want to ensure that there are no strands wrapped around the center conductor. This shows this is a clean cut. From here, we simply take the connector, place it on, and push accordingly, taking the protector off, giving it a twist and a push, a twist and a push, until we have it flush inside with the insulator. Once we have ensured that it is flush and that there are no strands of ground wire wrapped around the center conductor, we will finish this procedure by installing the tool and compressing. If we need to trim, take your wire cutters and simply trim just a little bit above the end of the connector. Once we have done with that, we will take and apply the weatherproof tape, which we have and we start at the very top. After the connector has been put on and tightened, we start on the flange and wrap it. Once you have connected the connector that you just installed to either a ground block or the radio, you'll start putting the tape on at the top of the ferrule, wrapping it tightly around, past the bottom and onto the cable itself. A simple, small wire tie would be acceptable to keep the tape there in place. Another method is to use vapor wrap, or in this case, heat shrink. You will always mark the cables red for receive, blue for transmit, at the radio, the ground block, and the indoor unit.